All right, first thing for today, I'll go over any questions that you may have. I suggested part 1 last night. You did it, fine. If not, hey, Regents is in 2 weeks. Please do, again, I know there's a lot of hands. You know my rule. Don't ask a question because you didn't do it. Don't ask a question because you don't know if you have the right answer or not. All right, so I'm going to go around this way right here. I'm going to go Nika, Tom, Mason, Jack. Yes? Is that a hand? Okay, I'll go around here. All right, with you 4. Nika, start us off. On number 4. All right, no problem. Let's go to number 4. Why are they similar? Here's why. 65 right here. These are supplementary, so that was also 65 when you do 180 minus 115. So you have one pair of angles right here that are congruent. Also, the vertical angles. And the main way to prove 2 triangles similar for us is angle-angle, which you have here. So that's why the 2 triangles would have been similar. You had 2 pairs of angles. So then from there, you need to put it into a proportion. Correct. That matches up the sides. Yes. Yep. That's where that was. That's where the ratio came from. The proportion came from. Good. Angle-angle. Oh, look at that. 2 birds, 1 stone. Oh, yeah. Number 22. Okay, 22. You got to first talk to me here, Mason, so I can try to help you personally with your issues. Yeah, math issues. You like that, Jack?
So, first of all, I don't know which arc it was talking about. And also, if it was going to the big arc, I don't remember how to find it.
So which expression represents the length of arc AB in inches? Okay. You got a point there which arc you're talking about. I would hope, though, the one would be there and the other one would not be on the multiple choice. So, all right, so I'm just going to go with the minor arc. All right, so how do I – it's a formula. Let me – here we go. There's a formula to find the arc. And, again, and not knocking you at all right, if you're doing this, and I have no idea, I don't remember the arc formula, where can I go? Cold hard facts. All right, I'm sure it's in there. All right, I'm sure it's in there. The formula we needed, ready, was the measure of the arc in degrees over 360 times circumference. That's the one I needed here, times circumference. So in degrees, the measure of the arc was $120 over 360 times pi. What was your diameter here? 12. And I can't read the other choices below. What are we looking for, the other choices below there? Yeah, so here you go. 120 over 360 reduces down to 1/3 times 12 pi. So number 4. Okay? Jack. Okay, talk to me. Good question. I was hoping somebody would ask this. Okay, well, easy question here. What's the figure? Triangle. And we're asking for the area. What's your formula for an area of a triangle? 1/2 BH, and that's where I assumed most of you probably started. 1/2 BH. The base could be any side. But what's not convenient here, Jack, about any of the 3 sides? Can't count any of them. That's not horizontal or vertical. Everyone else in agreement with Jack and I? We can't count them. And do I really want to get distance formula? No. And then the height would have to, I got to make sure the height is perpendicular to it. It's a whole mess. So that right there is not going to help me. See you later. What is going to help me, and I only went through this maybe once or twice and maybe had a homework problem on it, box the sucker in. Put a box around it. So the box touches every vertex. Because what happens when you put a box around it? You create 3 what? Right triangles, which now, Jack, we can count. So the first thing I'm going to do, and you guys can do this on your own here, I'm going to find the area of the box, length times width. And then I have, again, 1, 2, 3 triangles I'm going to use your 1/2 base times height on. And then subtract that from the box. Okay? Good deal? All right. I don't know if people got in desperation mode and started pulling this business. Not too sure what you did when you got to here or here, but okay, counting the boxes inside, that's big time desperation. All right. Everyone else all right on that? That comes up more. I've seen that come up a lot last couple of years, Jack, so good question. All right, box it in. Part ones, anything else here? Part ones, because I got to do that proof today. Whenever we get to it, we'll get to it, but it's going to get done today. Nico?
I couldn't find it in the packet. I was wondering if we could go over like the rules for the Centroid and all that kind of those 3 ones, like the ortho center and I forget the name of the other one.
Okay. I'll even save. Yep. I'll save yourself some time and I'll tell you just which ones you should know. How about that? Okay, so I'll just start with the one you mentioned first, which is the 3 medians intersect at the centroid. And anybody remember the rule for centroid? This is on the Regents. You probably did it. It was probably one last night. Probably on there somewhere last night, I believe. 18. Yep. Okay, so if you want to go to number 18, anybody remember the centroid rule? See, it tells me SC, KE, and RL are all medians. They intersect at M, which means M's the centroid. Anybody remember the rule? Billy? 2 to 1. So ready? Basically, if I take one median right now, let me take KE, everyone. Take a look at KE. KM is double the length of ME. SM is double the length of MC. RM is double the length of ML. That's where that 2 to 1 comes from. Okay, and let's see, which one is always true? 3 times MC equals SC. MC equals 1/3 of SM. I don't know, let's put some actual lengths on here. Let's see. MC, let's say if that's 2, what's SM? 4? All right, you tell me, is 3 times MC equal to the total length of SC? 3 times MC, is that equal to the total length of SC? How long is SC? 6. How long is MC? 2. 2 times 3? 6. And that was the correct answer, yes? 1? Yep. All right. I got to go back to the other ones. So 3 medians, centroid. I'm just going to put 2 to 1 rule. Anybody remember the other special ones? There's orthocenter. Anybody remember how the orthocenter was formed? All 3 altitudes. There was not a rule for that. Anybody remember the other special names? In center, okay. Anybody remember how the in center was formed? 3 angle bisectors, yep. And I'm just going to, for the Regents exam, that's really as much as I'm going to have you know. The in centers, the 3 angle bisectors, and there was one more. Circumcenter. And that was by the 3 perpendicular bisectors. And I will have you know the rule here, because I don't know if this will come up or not. See if anybody can finish this. The circumcenter, when you find it, is equidistant from the, this is equidistant from the sides, equidistant from the vertices, yes. And I tell you guys that because sometimes what comes up is, hey, I'm on a playground right now. I got swing set over here. I got the slide over here. And what do I have? The teeter-totter, the seesaw, whatever you guys call it nowadays over here. Where can I place a water fountain equal distant away from all three? Three perpendicular bisectors, circumcenter. That's where I'm going to place the water fountain. All right. How about that, Nika? Anything else on part one, or just anything in general here? Your call here. I'm going to need at least 15 minutes at the end to do the proof. Naam. Yep. Here's my requirement. You show me what numbers you're plugging in, and then you can go right to the answer if you want. Bare minimum, I need 2 steps. Show me what numbers you're plugging in and how you're doing it, and then what's our final answer. Whatever's in between is up to you, but do I need to see the distance formula written out? X's and X2, X1s, Y2s, Y1s? No. Nope. Billy. I would know them, yeah. You, without a doubt, you should be able to construct these in 2 weeks. Without a doubt. Now, will they get this hardcore, construct this? No. But you've already had one construct a median on this exam for you guys that have been doing the problems, right? You already had to construct a median, so everything else, fair game. Jack, 19, everybody, 19. Okay, question for you, Jack. It says it's regular, which means what to us? If that's a regular pentagon right there, a polygon, what's regular mean? Let me open it up to anybody. Regular, all the sides, all angles are equal. All right, what do I mean, Jack, by carry the figure onto itself? You see this pentagon right here? I want another one that looks exactly like it. How many degrees is it going to take me to make one that looks exactly like it? Okay. Well, okay, but it says that's not a choice, unfortunately. Yeah, 360 would work. You're absolutely right. 360, but that's not a choice for me. So I got to find something else. All right, and to find something else, every time I turn it from vertice to vertice, I'm going to get that pentagon back. So how many times could I turn it before I get back to the beginning and see that pentagon again? 1, 2, 3, 4, 5 times. So I could divide 360 by 5. What was that, 72? Oh, still not an answer though, Jack. Darn it. But can I go another 72? Right? What's that one? 1. Oh, still not 1. I can still. Every time I go 72 degrees, it's going to give me that pentagon back. Okay. That's a great question because a lot of people know how to find this, and then they panic because it's not a choice. Every time you go 72 degrees, you're going to get it back. Others, let's go. Anything else? All right, here we go. Part 4. Let's do it. Let's do it. Yeah.
I have one on question number 20. I forget how to do the equation for the circles. Like what numbers do you plug in for what?
Okay, here we go, everyone. Question 20 before we get to the proof. Right now, I don't even care what the multiple choices say, guys. This might be a part 2 question where you have to do everything out on your own. Write the equation of this circle, part 2. I could see this being an easy 2-pointer. So if you remember the formula, x minus h all squared plus y minus k all squared equals r squared. Anybody remember H and K? Those are the center point. That's the center point. So everyone go to the graph right now. Find the coordinate of O. Over and up, how many? Over 5, up 2. All right, now what gets plugged into the equation, though? X it's just minus, it's here you go. Make it easy on you. Ready? It's the opposite. It's the opposite. X minus 5 squared plus y minus 2 squared. It's the opposite. Same thing. If I asked you to use the equation to take out the center, just take the opposite of what's in there. Can you guys find how long the radius is in that circle? 4, but what am I going to plug into the equation? 4 squared or 16. Everyone see where that comes from, the 16. So if this was a part 2 question, there's the equation of that circle. But as you can tell from the multiple choices, it doesn't even look like that. Now, better not be. We're in trouble if it is. Okay. Everyone good there? All right, now look at the multiple choices. Oh boy. What are we gonna have to do to these multiple choices to put it in that form we left it in? Complete the square. All right. Have I gone over what's probably going to be guaranteed on this Regents? Yet? What have I said that's guaranteed? Partition, a proof in part 4, construction, complete the square. It's going to be on there. You're going to have to complete the square to get the circle formula. All right, so let's go to number 1 right first. Let's go to number 1. Because this was not a big success rate when we did this during the circle unit. First thing, make sure the number's on the other side, is it? Okay, if it's not, move it over. It's already over there. Group your X's and Y's. Look at you guys, that's already done. So now we can attack complete the square. So you have x squared plus 10x. You have to add a certain number now. How do you find that number? Go ahead, John.
Divide the number with the third in half and then square.
Take your b value. Everyone do it in your head. Half that number squared. Half that number squared. What is it? 25. Now do the same thing for the y's. Take half of 4 and square it. What's that new number I'm adding? 4. Half of 4 is 2. 2 squared is 4. And then what do you got to make sure you do on the right side? Whatever you added on the left, you add to the right. So you added a 25 and you added a 4. Okay, keep it going. Now we have to make it look like the circle formula. Anybody remember I don't like to call it a trick, but that's what it is. How to figure out what goes inside here. It's going to be X something. And you've already done it. Half the B value. What was half our B value here? Okay, so plus 5. And then what was your B value over here? Plus 2. And then you guys can calculate what new number do you get on the right. Okay, is this the equation we came up with? No, what's the only difference though? Because I don't want to do this 3 more times. Is the signs inside. I still got 16, right? All right, so I need different signs. So which one does it have to be up here? It's got to be choice 2. Okay, because I know negative 13 will lead me to 16, and there's only one more up there with negative 13. And that makes sense because look, now you're going to take half of negative 10 instead of positive 10 and get what? X minus 5. Okay? So be prepared to complete the square. Anthony, you good?
Yeah.
Okay. Yes.
Let's say the sort of question came up on part 2.
Yep.
Would you have to write like the equation without the numbers in it first, like with the K
No.
and the H?
Nope.
Okay.
That's kind of like what Nam was saying. I just plug it in.
Okay.
Yep. Plug it in. Anything, Tom?
Nothing.
What?
It's not important.
Everything is important. We are 2 weeks away.
It's not even related to math. I'm just wondering why they require.
No, it's a valid question. There is a completely valid answer to that, and the reason is so I don't change your answers. Not that I would, because I don't like many of you anyway. So, all right, too harsh. Couple days left. I change Jack answers, absolutely. Yep. If it meant 89 to a 90, I'd change it for you, Jack. But honestly, Tom, that's the reason why. All right, so teachers don't go back and erase something that's in pencil and write the correct work in. And then I know kids say, well, what if I use erasable pen? Okay, well, we can only go so far. Okay, but guaranteed, I'm not going to change any of your answers. Remy. Negative, it was just on that side. That's how the problem started. It became 16 when I added the 25 and the 4 from what I added over here. We okay? Okay. Emma. I hope not. Unless it's multiple choice, like in this case, but I don't see a part 2 doing it that way. No. Anything else? We all good? Thomas, yes. Is this a math related one?
Number 18.
You guys just don't want me to do the proof. That's all. You guys are just stalling. Go ahead, Thomas.
For the 18, it's the rule. I got the right answer. I just wanted you to explicitly state the rule.
For 18?
Yes.
What do you mean the rule?
How NC relates to SC.
Well, we said, okay, ready? Well, we said this was, if that's X, this is 2X, right? Good? Which means the following, the whole thing is 3X, right? So this, you could really say MC is a third of SC. But that's not what I want you to remember the 2-to-1 rule, all right, which is this is double this part. I think that's easier to remember. Good? You want to keep stalling here.
Can we do an angle bisect like a constructed angle?
I would love to, but there's a beautiful, either myself or Miss Venezia's voice telling you how to do it on the construction folder. All righty? Now, I'm doing the proof now. All right? We're doing the proof now. Because this thing was a beast. I'll give you time to set it up. This probably will take us the rest of the period, believe it or not. This thing was a beast last year. Okay, let's just talk let's talk proofs in general before we get to this one. First thing, part 4 will be a proof. There are 4 parts. Last part is part 4. It's 6 points. It's going to be a proof. Do I have any idea what type of proof it is? No. Would that be awesome if it was a coordinate geometry one where you had to graph and use slope, midpoint, distance? Sure, but I don't know. They don't seem to put those type on in June. All right, because the best of the best take it in June. So I don't know. If it was, it would be great. But if not, we got to be prepared for anything. Second thing, and this is not, I'm not joking around with this. Last 2 years, kids have tried to pull this whole business here because they're too lazy to write the givens. You get a point off for that. Okay, you get a point off. I don't care what you do now or while you're reviewing, but game time, you write every given in and the word given, not a big G. All right, not horizontal line. Okay, we have taken off the last 2 years. They require us to take off. I don't know if I've gone over this with you guys, but any abbreviations we've used through the course of the year are fair game. You use your own hieroglyphics or abbreviations, I can't vouch for you. Because remember, I do not look at your exam at all. Okay? You ready? Yikes. Let's do it. Let's dive right in. Okay, the whole thing's a parallelogram. Whole thing's a parallelogram. Okay? Which, by the way, can we get our cold hard facts out, please? Because I am not just going to give you the properties of a parallelogram easily. Find in your packet, it's towards the end of your cold hard facts where the properties are of all the quadrilaterals. Find your properties in there, please, so you can refer to them pretty quickly while we're doing this proof. Properties of a parallelogram. Know where it is in your sheet. Okay, here we go. Let's jump right in. And also remind me, I got to give you the January exam before you leave. All right, we are trying to prove. Everyone see the rectangle we're trying to prove. BEDF. BEDF, which is not a parallelogram. The bigger one is. So what I need to review with you first, the 3 ways to prove a rectangle. Here we go, 3 ways to prove a rectangle. First one, what type of angles are in a rectangle? So you could show me it's got 4 right angles. Very, very tough to do in a statement's reasons. Very easy to do if I had you graph it. You could use slopes. All right, so probably not the way we're going to do it here. Very tough to do in a statement's reasons. The other 2 ways to prove a rectangle, you need to show me it's a parallelogram first. And let's see if anybody can finish this. You could show me it's a parallelogram with, Caleb? 1 right angle. Good job. 1 right angle. Or you could show me it's a parallelogram with, and here's a hint, it cannot happen on this diagram. It's impossible to do. A parallelogram with,
So like 2 sets of congruent sides.
that would be a rhombus. Caleb? Congruent diagonals. Everyone see why that's impossible here? Doesn't have any diagonals. So there are the 3 ways to prove a rectangle. 4 right angles, a parallelogram with 1 right angle, or a parallelogram with congruent diagonals. So here's, off of what I said here, this is the way we're going to do it. We're going to show it's a parallelogram first, then show it's got a right angle. All right. BEDF. I need to know why this is a parallelogram and how you're going to do it. But remember, the whole thing is a parallelogram. Whole thing is a parallelogram. So can you get me any opposite sides parallel? Can you get me any opposite sides congruent here, knowing the huge one's a parallelogram? Billy, what do you got for me? Or what? Okay, let's. I'm going to take it from there. BC is parallel. Some of you guys don't know where we're going with this, but we're going somewhere. BC parallel to AD. It's been a while. That's why we review. Anybody remember the reason? What do you got, Billy? Okay, that's fine. I think we wrote this. Parallelogram implies, again, shorthand you can use. Opposite sides parallel. Thomas.
Angle EDF is congruent to AFB
Okay, where are you going with that?
because this is just the reason, but
Hey, whoa. Say those angles again.
EDF and AFB.
They're not part of the parallelogram. This one, ABE is the angle in the parallelogram, not FBE. You see what I'm saying? You're giving me this angle, but this is the angle in the parallelogram right there. So those aren't congruent. See what I mean? Or no? Well, look, you gave me this angle right here, FBE. That's what you said, right? That's not the full angle in this parallelogram. Say those angles again. We're getting confused.
I want to use the opposite angles are equal as parallel lines.
When's that a theorem?
Also,
So you want to say these two right here?
yeah.
Okay, where are you going with that?
Because if you can say that those two are congruent and AFB is a right angle, you can say that they're both right angles.
Okay.
And then you can prove that and then you can say that EF is the right angle and the opposite as well.
So you're going to get this a right angle.
Yeah.
Then you got to get this one, and this one to have 4. See what I mean?
Yeah.
Well, you can try it out. That's fine. I see where you're going, but I'm just telling you, eventually, the way you're doing it, I need right angles shown right there. I need all 4 of them. Okay, not 2, not 1. I need all 4. Okay, good. All right, let me go back to what Billy just gave us here, which are these whole sides are parallel. Anybody remember why we could say the pieces are? Jack? I think we use parts, but you can use segments. That's fine. Yep. So now we're going to say BE is parallel to FD. Parts or segments of parallel lines are parallel. That's a 3. I have to ask you this now, because hopefully maybe we're at this point. What else would I need to make this into a parallelogram now? I have one pair of opposite sides parallel. What other or anything that's going to transform this into a parallelogram now? One thing, Anthony. I could prove these two parallel, or anybody remember another way? Emma. Still won't do it. Not combined with this. Not combined with that. That still won't do it. Claudia. Prove these parallel sides congruent. So you have 1 of 2 options. You can do this, if you can, or you can do this, if you can get them congruent. You can get them congruent. You can get them congruent. Anybody see what they made for you on the sides here? Triangles. What can we do? What are we pretty good at here? Proving them congruent. Watch the plan right now, because I'm going to have you go with your groups here and finish this. Can you prove the triangles congruent? Yes, you can. Okay, you're going to have to discuss that in your group. You can prove them congruent. Once you prove them congruent, what says now that EC and AF are congruent? CPCTC. And then how can you go from these sides to FD and BE being congruent? Subtraction. Okay, so that's the plan right now. You guys are in charge. Get BE congruent to FD. Anthony.
Could you also prove the triangles congruent and then say that BF and BD are congruent?
But that won't be enough. Parallel and 1 congruent like that's not enough.
Yeah, but then you can say that parallel.
Oh, you could say both pair are congruent.
You can't say they're parallel.
You can't have this. No, that won't. Triangles CPCTC doesn't give you parallel lines.
I know, I'm saying, but is there another way that we could get BF and BD parallel?
Not that I know of. Okay. All right. So that's your goal right now. Get me BE and FD congruent. Let's go. And I'll pass around your Regents exams and help you out. Get BE and FD congruent, please. Get BE and FD congruent. Prove the triangles congruent. Use your properties of a parallelogram. You already have the right angles. Make sure they go in your proof. Make sure the right angles go in your proof, and then find either 2 sides, an angle and a side,